welcome to everybody. Just a little bit of housekeeping. If I can ask all of you, please, to keep your lines on mute. Really want to encourage as many questions as possible. So there will be a good amount of time for Dudley to answer some questions towards the end. Please type your questions here. That's in the chat box, okay? So at the end of the session, I'm going to go through, pick out those questions and present those to Dudley, okay? If it's something quite specific, I might ask you to unmute your line and then you can get involved directly. So just a quick introduction. For those of you who aren't members of the Packaging Society today, please reach out to either Ian Morris, myself, or my dad, Tim Barbary. We'd love to speak to you about how you can get much more out of the Midlands Packaging Society. And even if you wanted to help more directly with the committee, you'd be more than welcome to get more involved in our activities as well, to help plan and design some of these events that we put on. So without further ado, I'd like to introduce a very good friend of mine, Dudley Jones. He's been kind enough to put this presentation together today, representing Aquapak. Dudley, I've known for many years now, and we're very fortunate to have him on the call. A lot of the time we have technical experts on the call, and don't get me wrong, Dudley is quite technically aware, but Dudley's also one of the foremost brains in our industry commercially. So I've learned a great deal from Dudley over the years, and I think the project that he's got himself attached to here is quite possibly one of the most interesting that I've heard in the 20 years that I've been in the packaging industry. We've all got very used to over the years working with the OPPs and the polyesters and the OPAs and the different variety of plastic materials that we work with in the industry. This is probably the first one in the time that I've been in the industry, truly new material that can deliver some really interesting things. So I'm going to say thank you at this point and at the end, Dudley, for you supporting this webinar, and thank you very much for showing up. And I'll pass over to you to run through your slide deck. And again, just to remind you, please, all of you in attendance, please do post your questions in the chat box. Dudley, over to you if you want to unmute your line.
Thank you, Liam. Thank you, Liam. Firstly, thank you for the introduction, Liam. Obviously overhyped as always, but I do enjoy it. Thank you very much. As Liam says, we've worked together for many years, so we can get away with calling each other different things. But thank you very much, Liam. Much appreciated. My name is Dudley Jones, and I work for a company based in Birmingham called Aquapak Polymers. We create a product that is called Hydropol. It is a resin. I'll explain to you more about the resin in a minute. But what we basically say is for this seminar, or this webinar, should I say, we're going to focus more around barrier paper. I think it's a really hot topic at the moment. And as Liam says, we've been trying to build paper products for the last 3 to 5 years in the industry. This is a unique material that can aid in the recycling of paper and board, while adding barrier and functionality on its own or in combination with other materials and technologies. So I just wanted to give you a little bit of information about Aquapak. So Aquapak as a company has been going for a number of years, the last 10 years. The last 3 years we've been at the new facility in Birmingham. So if anybody's always welcome to come and see the facility. It's on the old site of the Longbridge car factories. So it's a rejuvenation area, and it's a perfect fit for this business. So we work out of a new operation, and historically we've had a large number of technical people within the business, which we still retain. So about 30% of the people within our company today are technical experts. We have 12 dedicated to R&D, of which 6 have PhDs, led by John Williams. And we continually look and win awards, etc. We've just won the Forever Green Award. You might have seen the investment with Birmingham University and Siemens for the study partnerships. So a company that works with, here in our region, Aston, Birmingham, Loughborough, but lots of universities developing different types of products. So we focus on formulation. So we look at material combination and characterization and IP generation. From that, we also look at the manufacturing process. We have a full-scale factory here with 2 compounding lines, and we also focus on process IP. So there's something like 17 patents in and around the product and the process itself to make this resin. And it's really just about creating materials for the future, working hand in hand with the different institutions, whether it be RAP or CEPI or OPRL, etc., trying to create these future products of tomorrow. As I said, our purpose-built factory in Birmingham, we have 4,700 meters squared. We have 2 compounding lines currently with a capacity of 50,000 metric tons. This facility is scalable to 30,000 metric tons, and within a period of 12 to 16 months, we can put in compounders into the business. So just to give you a flavour of the capacity, if you put a 10 GSM coating onto paper, 15,000 metric tons would roughly deliver around about 1 billion square meters of flexible packaging. So it's a scalable technology. So we're not working from labs. We are actually creating materials in factories at scale for consumption. So what is Hydropol? Hydropol is an innovative water-soluble biodegradable polymer which can be used to manufacture recycled barrier paper packaging. As I said, I'm focusing on barrier paper today, but we can also manufacture film. So the Hydropol resin can be manufactured into film, or it can be thermally processed through a blown film line, and it can also be thermally processed, extrusion coated onto paper, and it can also be cast as well on a film. So as I said, we're going to focus on barrier paper. So we can apply the Hydropol resin to paper through normal extrusion equipment. So if you've got a tandem extruder or an extruder that normally applies PE, you can pretty much apply Hydropol to the paper. There are some nuances that need to be worked through, but we've got a good experience of working through people with different types of machines, with different types of dies, with different types of machine loading, etc. So a good knowledge of different types of ways of applying this material to paper using equipment that is already available today and being used to coat PE. It provides excellent barrier against oil and grease. It has gas or OTR barrier and is heat sealable for form fill seal applications. The advance is circularity is the fact that it has multiple end of life options. So in recycling, in paper recycling, it solubilizes in a typical standard mill pulper at the normal temperatures that I think they range from 40 to 60 Celsius. So the tests have been done. I'll talk to you about that in a minute. But basically, it solubilizes in the typical pulper temperatures and durations. So within 10 minutes, it basically breaks down and it facilitates fiber dispersion. So you get a cleaner fraction when Hydropol and paper are put into a recycling mill. Once it separates, it's a much cleaner fraction than the PE. When the PE goes through a recycling mill, it takes some of those fibers with it. And I think a fiber loss in a recycling mill is around 5%. So if everybody used Hydropol, we could see a 5% improvement in cleaner fractions through the mill. It does not impact paper sheet appearance or impart adhesiveness. And our research suggests that Hydropol decreases stickies and increases pulp drainage. It is also biodegraded within mill anaerobic and aerobic systems as part of its intended use. So they can actually, once this material solubilizes, they can then use this material in their anaerobic systems if they have them. It's also non-toxic, it's marine safe, and there are no microplastics. So its ability to either be collected at the curb, so curbside collection in the normal paper stream, is the way to go with paper Hydropol. If it falls outside of the recycling system, If it goes into the environment on land over time, it will degrade and compost. And if it falls into water, it will solubilize and the paper will break up as well. So ultimately, multiple end of life with no toxicity and no microplastics. In terms of what we have commercially available today, there are three streams or three sales streams that we're working with here at Aquapak. We can produce resin for monofilm, as I have said. We can also produce resin for co-extruded films. So we have our material also has OTR, so you can use it as a replacement for EVOH in co-extrusions. You can also co-extrude with PE and Hydropol to make different types of materials, or you can just make monofilms. We extrusion coat onto board and paper with another grade, and we have another grade for fibre and non-wovens. So with fibre and non-wovens, we basically, with our resin, can create a thread that is then woven, and a sheet is soluble. Under validation in development, we have a combination of biohybrids and cellulose. So we're looking at our material with different materials, specifically cellulose. So our foundation work and development work in R&D has shown that this is an area that is very interesting, and we move forward in this once we realise that the strength will match aluminium. So very unique materials being created, and then also injection moulding. So you can see that we are working in different areas, but today we have three commercially available routes for product. Where do we see our product being used currently? We've seen it being used in mailer bags. So people use it in combination with paper laminated to Hydropol film for mailer bags. You can reduce your thickness of paper and you get improved puncture resistance and strength, which I'll show you the features of the product in a minute. In non-wovens, I've spoken to you about, so they would be wipes or sheets that can be solubilized. In healthcare, it's bags to stop contamination of used clothes, specifically during COVID, where people didn't want any contact. They just put the clothes into the bags and the bags into the washing machines. For food packaging, we see it in a number of areas, and I'm going to focus on that a little bit more in the presentation. Garment bags, leave no trace garment bags, so that would just be a mono bag for clothing. And then industrials, we see different opportunities in industrial applications. For extrusion coating, we developed this material in conjunction with a number of people. It was Itena, Tampere University, and SAM North America, where we took the resin and we've moved it from pilot to mid-scale size. So this was done last year or the year before, where we have a full size, well, it's 900 millimeters wide in SAM, a line that is capable to run Hydropol if people want to do pilot tests. We can also run that at, in the Nordics. We also have a facility for pilot trials in the Nordics, and potentially here also in the UK. On machine performance trials, we assess stability, run speeds, drawdown rates, adhesion to paper. We ran different types of paper with different types of primers. What I will say at this stage, if we run Hydropol on its own through an extruder, we do need to prime the paper at this stage because of the crystallinity of the product when it hits the surface of the paper. That is, we're looking into developments with non-primer, but that's some way off. So you do have to prime before you coat. And then on top of that, once we've done all the tests, we took all of these structures through recyclability and end-of-life testing. So we're running commercially. Commercial product is available from Italy and Ukraine. They are on full-size machines. So, 1.3, 1.4 meter wide, even further, 2 meters. And all of these machines that we're qualifying on prime in line. So they prime in line, and then they extrusion coat the material on top. If we look at the functionality of the product, here we have, we're looking at tensile strength. You've got 4 bars. Here you have a 50 GSM craft uncoated, 50 GSM craft coated with 20 GSM of Hydropol. And here you have a 40 GSM recycled, 25 GSM coated of Hydropol. The light blue is machine direction and dark blue is the cross machine direction. So you can see in both instances, we see Hydropol adding strength to the paper. So in a way, lightweight, inherently weak substrates could see significant strength increase with the addition of Hydropol. But also, if you're thinking about down gauging, Hydropol will add strength. If we think about puncture resistance, again, we've got a 50 GSM craft uncoated, a 40 GSM recycled uncoated, and then we have them coated with a 20 GSM and 25 GSM of Hydropol. And you can see the puncture resistance is dramatically improved. So 50%, 45 to 50% improvement in puncture resistance. In terms of sealability, the sealing tests were taken at 1 bar, 15 psi, dwell time of half a second using flat sealing bars. We got full fiber tear at 150 degrees C, but we were making seals as low as 100, and we have seen seals. You can seal up to 200. So it's a good sealing range, and it gives good strength in terms of its sealing properties. In terms of oxygen barrier, obviously oxygen depends at the different RH. As we relate to paper, we look at the 70 percentile because beyond that, paper swells. So realistically, we're looking at around about 1.5. If we're talking tropical, it's 3. Around about 50, it's 1. So it's a good OTR barrier in itself inherently. The material has been run on horizontal and vertical packing lines. It has also been made into stand-up pouches on tatami machines. So I'm just going to quickly show you a machine trial. So, yeah. So the package on the right was basically a rotogravure surface printed with cold seal, and the one on the right was a flexo printed surface printed paper. So both run on machines. The other interesting thing is when the material runs on the machines, it performs more like plastic. So you don't get the tears, you don't get the things that you would normally get with like paper with a dispersion on or something like that, because you need to maybe alter your forming colors, all your different things, because sharpness and paper doesn't work. But with this, it actually performs more like plastic, and therefore you don't really need to do your machine modifications like I've seen previously. So it's quite interesting. As I said, our recycle validation study was conducted with DS Smith. We confirm 100% recyclability of fiber and no ill effects on wet end chemistry and paper mills. These are published papers. I can give you access to all of these. If anybody needs this, please at the end just ask, and I confirm. I can send you all of the materials with confirmation around biodegradability, compostability, marine safe, recycle this study, etc. But basically, you can see Hydropol coated paper, past recyclability with an A rating against the evaluation protocol MC 5012-017. If you look at the actual numbers of that, so we took it was 100 GSM recycled liner. We coated it with Hydropol. We got 0 coarse rejects, very low micro stickies, no fiber flakes, adhesiveness was absent, and when it came to optical, we got a level 1. So it was a good result in terms of its recyclability credentials. So how do we actually make products with this material? There are a number of ways, and when it comes to paper, what we're actually doing is we can either co-extrude onto paper, we can monocoat onto paper, or we could laminate. And we can laminate through extrusion or through adhesive. So it's been quite interesting trying these different variations of products. What I've tried to do was give you a flavor of just some of the products that we're creating already and other companies that we're working with are creating. So what they'll normally do is just take a paper, you know, a long fiber or a short fiber. They'll prime it and then they will extrusion coat Hydropol onto it. So in terms of barrier, you don't really get much WVTR there because there's nothing for WVTR. You get good OTR. So for some products, that's okay. You know, that's generally okay. You don't necessarily need a combination of both. So if OTR is fine, then that's the way to go here on this right-hand side. If you want WVTR, we have a customer who's taken the base sheets, extrusion coated onto the paper. They've then printed and applied a WVTR dispersion coating on the top. And that got them to a WVTR of, I think it was around about 10 to 15 or 10 to 12 at 50. So again, some form of WVTR. And this product actually was the one that achieved OPRL status. What you can also do is you can take a metallized paper and you can apply Hydropol. That gives you WVTR, OTR less than 1. So again, different ways of combining materials. And this isn't the only way. What I'm trying to do with customers is just start talking about ways of putting products together. Because, you know, it's a new material. It could be used in different ways. You can combine it with different products. You know, if what's that one? If I look at this, if I go back here, we could run a coax here. So this could be a coax of Hydropol PE. It could be a coax of Hydropol PLA. You know, there are lots of different things as we're starting to put products and materials together. But at this stage, as I see in paper, the barriers are coming from a combination of technologies. It's not just one. So metallization will give you something, but it doesn't give you the functionality. So you need to combine it with something to give the functionality, or maybe the barrier. So we're at stages where we're needing multiple products to create these functional barrier paper products. As I said, you could also adhesive laminate with the material. So other people can produce the film. So they produce the film in 15 to 25 microns. It is then adhesive laminated to either paper or, you know, something like a cell O&M. You could create a high barrier bio product that would give you, you know, OTR and WVTR that is then biodegradable. Or you just take a standard paper, adhesive laminate it to Hydropol film, and you can make mailer bags, or you could make pillow packs that hold air, or you could make butcher block sheets, or, you know, whatever you want to do. You know, think of it as either replacement to PE but also adding functionality and barrier. You can run a WVTR dispersion on the top and get some WVTR from it. So again, different ways of just putting products together. As I said, we have a customer who has produced it's a WVTR overlacquer, flexo printed paper, extrusion coated to Hydropol. That passed the CEPI for Evergreen test and was given an OPRL logo. It's for short shelf life crisps. They get a 4-week shelf life on crisps. Some areas in the market, 4 weeks is fine. This company is also working with a metallized version that is in development for 6 months. So again, key is the product, if it passes the recycling tests, it will be given OPRL approval. So really, just to kind of summarize, and you look at the USPs of Hydropol, it's multiple end of life. Yeah, so it's recyclability in standard mills, compostable and biodegradable. It solubilizes in water with 0 microplastics, and it's marine safe. So if we think about curbside collection, if we think about ease of consumer disposal in the paper stream, if we think about what happens if it escapes from the system, how can we deal with that? So we give it multiple end of life, which is very unique. It has a less than 1 OTR at 2350% RH, so good gas barrier. It's got kit 12 in terms of fat and grease, and there is also some residuant chemical resistance and certain alcohols. It doesn't like water. It is hydrophilic, of course, but there are certain alcohols and chemicals that work with Hydropol. It is direct food compliant. So you can put it in a pack on the inside, direct contact with food. It gives you increased puncture resistance. It adds strength to paper, so you don't need to modify your machines, and you can down gauge your paper. It's got a large sealing range. It's got a strong sealing capability, so it works for standard but also large pack formats where maybe some of these heat seal lacquers aren't working as well as they should. It promotes circularity in the recycling process. It's an enhancer for recycling, and it's OPRL approval if you can show it past the recyclability tests. And then obviously with paper, it's got less than 50% fiber content, so you don't pay the plastic tax. So that's it really. That's a kind of an overview. If I guess there's an opportunity for questions, but if anyone doesn't feel like asking questions today when you get the presentation.
We've got plenty, as I was fully expecting. So get ready for the Spanish Inquisition. Just to say, first of all, Dudley, thank you so much for that presentation. I hope everybody on the call enjoyed it as much as I did. Again, for those of you who haven't seen in the comments, slides will be made available. YouTube video will be made available as well. So, and I hope you'll agree, really, really fascinating technology. So first question here, and Carlo's put a number of questions here, Dudley. Carlo Ranucci asks, is the coating affected by humidity?
Well, it's hydrophilic. So if it's and you saw the OTR comparison as relative humidity increases. So the answer is yes. Okay. I'm going to ask Carlo's second question here. Could you use it for BOPP? I'm not sure quite what that question means. What can it be? Carlo, I'll invite you to unmute yourself. What does that question mean? Could it be used for BOPP? We can extrusion coat onto BOPP, or are they asking for as a replacement to BOPP? That is exactly what I'm not sure. Carlo, please go ahead.
Yeah, the question was exactly as the answer has been. Okay. So I can apply on polyester, I can apply on polypropylene.
Yep, you can. Yep.
And so it has been of course, I guess you
need to prime, of course. Yeah, you need to prime.
Yeah. Thank you, Carlo. Hopefully that your question's answered. I'll just mute you if that's okay, Carlo. And I'm going to come to a question from Naomi Carlin. What element does it break down into? Now, I do think that you did that question, didn't you? So, yeah. So I will actually engage with Naomi. I will send her the papers afterwards. So I will send everybody on the call. So again, salesperson, it basically solubilizes. It doesn't disappear, but it's safe. It's marine safe. It's toxic safe. If you feed it bacteria, then it will obviously create CO2 in aerobic digestion. I am not fully, I would rather send Naomi exactly the data, which I will do, Naomi. Okay, cool. That's absolutely fine. Well, Naomi's coming with a number of other questions here. Can you laminate already to Can you laminate already printed board? So if you've got a pre-printed board, could you laminate this to pre-printed board? I guess if it's not die cut, then.
Well, yeah, I mean, I don't see why not. I'm just thinking to the extruders that I used to work on. So we brought the board in and then we just extrusion coated. So if it was printed, I don't see why it wouldn't. Would you want it to extrusion coat onto the print or onto the board? Again, you just prime it and go forward.
Exactly.
So I don't see an issue. I don't see an issue.
How does it behave in the chill room change? The chill chain.
So for freeze dried and frozen, yeah, because so we're actually studying this now. We don't know is the answer, but a customer has asked specifically. Within a freeze-dried environment, there isn't a lot of humidity actually. So we're running two tests. We're running frozen as if you would buy it in a supermarket in a chiller box at Iceland, and then we're also looking at in a freeze-dried environment. So we don't know the answer yet, to be honest. We don't know.
Another question here. Thank you. Naomi's got another question in just a moment. Carla Ranucci as well asked a subsequent question. Is the barrier sufficient for aroma and off odors?
Yes.
Okay,
so it is.
cool.
So yeah, if you wanted to use this for coffee and different things, yes, it is an aroma barrier.
Yeah, sometimes in the dairy market as well, aroma can be obviously aroma. Some cheeses are a little bit smelly. So
smelly cheese, yeah, of course, yeah. Yes, it would be. Yeah.
Cool. And then next I've got here again back to Naomi. She said, when coating papers to improve strength, will the impact EPR due to wet strength increase? So this is obviously when board gets wet, its burst resistance and tear resistance will degrade. It's increasing as this is something that DEFRA are targeting. So when coating papers to improve strength, will this impact the EPR due to wet strength increasing, as this is something that DEFRA are targeting? So I'm guessing the answer's got to be yes, isn't it? I mean, it's the best way to describe this. I actually visited Dudley just the other day, and fascinating facility. The best way, if you can't visualize it, and they do have reels of this Hydropol product in the factory, it looks and feels very similar to a polyethylene once extruded into a film, which I'm sure you'll all be really familiar with. So if you imagine it from a technical perspective as coating a paper with a polyethylene, apart from the special elements of Hydropol, you're pretty much going to get all of the other benefits of that. The really cool thing is that, for those familiar with the paper recycling process, the natural process for paper recycling means that the material needs to be washed first at the beginning of the process. That's done at about 40 to 50 degrees, the water. Just by chance, Hydropol starts to solubilize at 35 degrees. So without changing any machines, any settings or any infrastructure, what you get left with are the clean fibers at the end and no contamination to the water table, which I have to say I'm particularly impressed with what these guys have achieved here. So that brings me to the bottom of the questions. We do have quite a bit of time left. So, Naomi, you'd be welcome to unmute yourself. You just put your hand up if you'd like to ask another question. You'll be welcome to.
Thank you. Sorry, I feel like I've spammed the chat, but my question around the EPR was the fact that due to us having to pay potentially higher fees when it comes to adding wet strength additives to paper in the future, is this something that will affect that? Do you know if that falls under sort of your radar to have a look at, as to if people are buying this, they may potentially incur more fees through EPR?
No, it wasn't. That wasn't what. No, I mean, I know we work with Forever Green, so we're on all of the committees for Forever Green. We just won the Innovation Award, but I don't know if we're looking at it with regards to what you just said. Okay. Yeah, so I don't know. I will ask the question, Naomi, again. Yeah.
Thank you, because I think a lot of people would be interested to see if there's an alternative to having something that could keep it paper stronger for things like paper bags and things like that, but without affecting the fees that they'll pay through EPR.
Yeah. Okay.
Thank you.
Interesting one.
One of the other interesting items could be as a lamination adhesive, of course, if you're buying a foil-based laminate and you want to separate the webs in order to get back to that neat aluminium that then can be recycled. Again, using it as a coating or an adhesive on an extrusion laminator. I mean, the possibilities here are really quite interesting. So we've got quite a few people on the call. I have to say thank you to Carla and Naomi for engaging. Are there any other questions? And of course, Gaynor, Denton Bray, I did answer your query in the chat. The slides will be made available and the video will be posted on YouTube. So all of this will be fully made available. Any other questions at all to do with the performance of the product? Sealing through contamination might be an interesting question. I know, Dudley, when we spoke, you did a lot of testing around sealing through contamination already, and nobody's asked that question quite yet. So do you want to just run through what your results were with regards to sealing through contamination and what you found as a team?
I think, well, Liam, I can't remember, to be honest. I don't remember. Was that us?
Yeah, no. So when we had spoken, we were talking about the melt flow characteristics of the material. The heat seal initiation temperature is quite low. So if I reflect back to my experience in the dairy market, it's not quite got the low heat seal initiation temperature of, let's say, a polyethylene, but it's within 10 degrees of a metallocene-based material. So it's pretty good. So what that will mean, of course, as well with the melt flow indices on the film, it will and should seal through contamination quite well. So for those markets like meat, where there's lots of blood, dairy, where there's lots of potato starch and little bits of fatty cheese that get caught in the seals, and all the other industries to do with coffee that I'm sure you guys are more than familiar with. This film should seal through contamination. Okay, we're not going to know until the case-by-case basis, but at least the lab test results would suggest that it does. So odor control on chocolate is important, according to Ian Morris. Hi, Ian. Did the customer trial on the horizontal form, fill and seal line in the video need this?
Odor control. There was no need for odor control. So the product basically on that video was 60 GSM paper, 20 GSM Hydropol, cold seal, ink on the surface with overlacquer. So there was no anything added extra for odor.
It's interesting. Thank you very much. I'm going to start bringing this to a close then. We do have 15 minutes left. Dudley's more than happy to stay. Are there any final questions before we wrap this up and bring this to a close? Excellent. Well, what I'll do is thank you very much again, Dudley, for your time. Really excellent presentation. I hope you all really enjoyed it. Please keep a look on your notifications for future webinars.